since voice search is a part of the voice commerce, and we can get a better sense of how customers are going to use voice recognition functionality from there. Voice commerce today is mostly related to the home assistant devices, so we're going to talk about those. For this presentation, I have used two articles or researches that showcase really interesting data on state of voice commerce, and they provide some counterpoints to each other. So this is a conclusion from one of those researches done by OCNC from December of 2017. They concluded that voice commerce has a big potential in the industry, and they have linked that potential with growing number of home assistant devices, which is really optimistic. So let's talk about voice shopping and home assistant devices. So customers are getting used to voice shopping mostly today through smart speakers and home assistant devices. Amazon dominates that market with Amazon Echo device, and with market share of 68%, but Google is slowly getting traction with their own home device. They have also announced a partnership with Walmart in late 2017 to offer voice shopping exclusively through their device. So going back to the research I have mentioned, OCNC concluded that most commonly shopped categories through voice are groceries with 20%, entertainment with 19%, electronics with 17%. These three are pretty close with percentages. And the fourth one is clothing with only 8%. They have also concluded that voice purchases tend to be standalone lower value items. And they have made a bold prediction that voice shopping in the US market will grow from $2 billion today to $40 billion in 2022. We're going to see what is different about that prediction. So right when I was doing the research for this presentation, an article came out that had some Amazon insider info, apparently. And they tell us a different story. So, but we'll get to that later. There are some inconveniences when using voice shopping on home assistant devices. It's primarily that it's not convenient to get any detailed info about the product, for example, product images or any specific, more extensive detail on the product. Also, there is an issue if the product's keyword change, the search results might change, and that might also confuse the users. Going back to the research I have mentioned, or info from Amazon employees, apparently 2% of the people who use Amazon Echo device have made a purchase with their voices in 2018 so far. And of the people who did make the purchase, most of them didn't make the purchase again. But more interestingly, people who did use the voice shopping feature again, they used it in a more extensive way. So not only did they make the purchase, but they also used the voice commands to update their account info and for tracking data. It's also important to note that Amazon actively tries to encourage voice shopping by offering special discounts and better deals. So the conclusion is that there is a potential in voice shopping, but there is not yet an established pattern that works out of the box and which is instantly recognizable for the users. So we talked about home assistant devices and voice commerce there, but what about regular web browsers? On our regular desktop and mobile devices, we have voice search functionalities like on Google, for example, and we have data for that. So Google voice search queries have grown 7 times since 2010. On Android, 1 of 5 searches are done by voice in the US. On Baidu, 1 of 10 searches are done by voice. And according to some poll, 1 of 3 users use voice recognition functionality on their mobile and desktop device daily. The number of voice searches continues to grow. And there is a prediction that 50% of the searches will be done by voice by 2020. So this is where the Web Speech API comes in. It aims to provide a speech input and text-to-speech functionality to regular browsers. Web apps are now able to handle voice data. It opens up interesting new possibilities for accessibility and control mechanisms. It aims to provide features which are not generally available to the regular accessibility software. It's important to note that this is still an experimental technology, and we're going to see the browser statistics and can I use data in the next slides. It consists of 2 main parts, speech recognition API, which provides ability to recognize voice from an audio input, and speech synthesis API, which is basically text-to-speech. So this is the speech recognition API browser support. As you can see on Chrome and Opera, it works right out of the box. I think it's for WebKit vendor prefix. But for Firefox, it requires a specific config flag to be set. It also has 63% of global browser support, which is, I think it's poor. For the speech synthesis API, the situation is a bit better. It has 80% of global browser support. I think that is because the specification is much simpler, and I think it's easier to implement. It works on most of the modern browsers. So we're going to focus on speech recognition API since we're using that to implement voice search in Magento 2. There are some quirks that developers and users need to be aware of. It requires internet connection to work on Chrome, and it's HTTPS only. But for development and testing purposes, this can be avoided by launching Chrome with a specific flag. If someone wants, I can share that part of the code later. Also, as I've said, it requires a config flag to work to be set in Firefox in order to work. So we're going to take a look at the properties, events, and methods of the API of the speech recognition API. So for properties, we have grammar and language options, and we can toggle between final and interim results and single and multiple results. Interim results means that we are getting the stream of voice recognition data. So we are getting, during the speech recognition event, the stream of data. And for final result, we only get when the event has finished. For single and multiple results, we can either return an array of results ordered by the accuracy, or we can return a single result. So in a stream, you would get either a stream of array of results or stream of single results. As for the event, we have a lot of events, but I put the ones that I think I use the most. So we have audio start, audio end, error, result, speech start, speech end, and some others. For methods, we only have 3, which are simple ones and straightforward. First is starting speech recognition. The other 2 are stopping speech recognition. One is with returning a result, and the other one is without returning the result. Here we can see an example of speech recognition data. We have set results to interim, and we use single results. So you can see a stream of result for a single speech recognition event. You can see the first speech recognition result, which has a lower confidence value, which is the measure of accuracy. So this result was returned even when the user hasn't finished speaking. And on the last one, we have a final result that has been returned after the event has ended. And you can notice that it has a much higher confidence and a correct transcript. So we also have to talk about accessibility when talking about voice recognition. Web Accessibility Initiative defines that voice recognition can be used to dictate a form in the field, activate links, menus, and allow a computer interaction and some other regular functions. People who will benefit from the speech recognition functionality, it's primarily people with physical disabilities who cannot use the keyboard or mouse, people with chronic conditions who need to limit or avoid using the keyboard and mouse, people with learning disabilities who need to use a voice rather than type, people with temporary limitations, and simply people who just prefer to speak rather than type, but this depends on the device type, situation, personal preference, and some other factors. So I'm going to showcase the code for this implementation. It's a very simple implementation, and you can see that I have divided the code into several sections to keep the presentation simple, but I'm going to show every section and talk about it separately. So we have a simple Magento 2 JavaScript require.js file. We are requiring jQuery Magento translate. We are triggering this on DOM ready. And you can see we have options section, setup, and functions. Functions sections are divided into event listeners and support functions. As for the options section, I wanted to keep the implementation also configurable as possible, so developers can define placeholder text that's going to be displayed once a user triggers the speech recognition event. We can define the speech recognition trigger, a button. We can define input field, where the final text will be inputted, and we are binding the form which are submitting in the end. We are also setting some internal variables that we will talk about on one of the next slides, and we are checking if the API is available to the browser. For the setup section, if the API is not available to the browser, we are hiding the button. But if it is, we are preparing the speech recognition. We are setting the options for it for interim results and single result, which is by default. We are calling the functions that I'm going to explain in the next slide, and we are setting the speech recognition specific event on result to a function. So for the event listeners, we have two. First one is for the button that will trigger the voice search. The next one is to keep track of the speech recognition event state and setting internal variables. So we keep track if the recognition has started, ended, or if it has an error. So we can avoid any future errors if, for example, if user clicks on the button multiple times. For the support functions, we have three. First one parses the speech recognition result that for the data we have seen on the previous slides. The next one starts voice recognition with the click of the button. It replaces the form input field with a placeholder text and starts the voice recognition. And final function is on result function, which basically each time the voice recognition returns a result, it inputs the text, and if that result is final, it's going to submit the form. So for the require.js config, we have standard mapping to the file we have just created. For the template file, for the header search template file, we have just a few modifications. We are calling the datamage, the function from datamage init in a form element. As you can see, we are calling it with default parameters. That is because I've set the default parameters to match the header search template. We are adding some IDs to keep everything simple. And we are adding the voice search button. This is how this is the final result. You can see the interim results being inputted and form being submitted and user being redirected to the search results page. So I wasn't sure about setting the interim results because I'm not sure if it's of some user experience concern, if it can confuse the user, but I thought for presentation purposes that this would look a bit cooler. So let's take this step by step. So if the API is not supported, voice search button will be hidden. So if it's supported, user can click on the button and user would be prompted to use of the microphone. When user gives the permission, the placeholder text would change to listening and user then can speak. And after the user has finished speaking, text will be added to the input form and form would be submitted and user would be redirected to the search results page. As I've said, this is only a very simple implementation. There are certainly some areas of improvement. For example, we can ask the user to confirm the input before submitting the form. We can cancel voice search if input hasn't been received after some time limit. I think the API also handles that, but we can add, for example, manual way to cancel. We can use the accuracy or confidence data we also get from the API to check if the result is good enough in order to be submitted. For example, if the user has stuttered or there was some background noise or interference that would mess up the result, we can ask the user to repeat the search. We can also do some user experience improvement, so better communication of the current state, recording, submitting the form, loading, and some others. For example, another improvement would be to open the product page for the first results page. That would be useful if the search returns only the one result. Alternatively, we can use a paid solution like a Google Cloud speech-to-text that has some advanced features like language recognition. So we can, in theory, enable users to search in their native language. I would also like to share some additional ideas. So we can implement fully voice-controlled shopping, or to take some clues from the voice shopping or voice commerce. We can not only implement voice search, but also adding product to the cart with voice, checking out with voice, and tracking order with voice. And also, we can go a step further and use the speech synthesis API to create some kind of voice-controlled on-screen assistant with some more advanced features like voice shortcuts, navigating menus, filling out contact forms, chat support, and some other functionality. But as we have seen, the results for voice commerce can be quite polarizing. People either use it extensively or don't use it at all. So more research is required in order to find a pattern that works with all the users. So to conclude, people are still getting accustomed to voice shopping, mostly through their home assistant and smart speaker devices. Voice search continues to grow across various desktop and mobile devices. Web Speech API is here to open up the door for the speech recognition functionality on regular browsers. It's instantly beneficial for accessibility and also has potential for regular use. But if you're going to implement this, consider adding it step by step, for example, starting with voice search, since there is a chance that a lot of users would use the voice search, and you can track those users, see how are they using it, if they're using it on a desktop device or a mobile device because it's more convenient. You can track which products are they searching for? Are they using it to for product discovery or shop for familiar items? Are they using it for convenience to, for example, avoid typing a product name with longer, that has lots of words? And if you decide to implement voice control functionality across many areas of your site, you can track which functionalities are used more and which are used less. Thank you for your attention. Let me know if you have any questions.
Google itself? Sorry, it's this language recognized by itself by Google, or we need to provide what language is spoken by person, some default data? Can we add it? Do you understand?
Yes, there is a language option in the API. If I understood correctly, you can set the language up along with the grammar and if you're using specific words. So yeah, there is an option in the API for that. Any more questions? Okay, thank you very much.
Just one more question.
Oh, one more question.
Oh, sorry.
No
Sorry to take your time. But have you experimented with your application? I mean, it's as you said, it's very simple. But is it effective? Is it effective with, I don't know, some noise in the background? Is it effective when a couple of people are talking in the background?
Yeah, I played around a bit. I don't know for the noise levels, but accuracy can vary sometimes depending on your pronunciation. If you have an accent, it can really go wrong. So I think it's very sensitive, I'd say. But for the regular use, I think it's okay, but I haven't tested it in non-ideal situations. So more testing is basically required. Thank you.